This is the MSC Arena. At the time of writing this video, the ship is somewhere around here, rounding the southern tip of Africa on its way from Singapore to the port of Valencia, Spain. From here to here, it will move somewhere around 236,000 tons of something. It might be full of muffins. It might be full of puffins. It might be full of puffin-shaped muffins called pamuffins that are about to become a smash hit in Spain when they get unloaded in Valencia. I don't know, you don't know, and people on board the ship don't even know. That's kind of the beauty of modern shipping. It doesn't matter. These containers, coming in lengths of 20 and 40 feet and standardized across the globe by the International Standards Organization, drastically changed the way that shipping works. Instead of inventing new kinds of ships and elaborate processes to move every kind of different thing imaginable, all the shipping industry needs to know how to do is move two different kinds of rectangles. The effects of this have been staggering. The port of Singapore, where the ship was loaded, can move around 220,000 of these containers every single day. But just because these containers are identical doesn't mean they aren't meticulously organized. In fact, if you look at the MSC Arena, the placement of these containers might look totally random, but that couldn't be further from the truth. When these containers were loaded in Singapore, every single one had been assigned that exact location on the ship. Place a container in the wrong spot, and the whole thing tips over, sinks, gets stalled in an unloading port, or, in a frankly shocking number of different ways, explodes. Organizing the containers on a container ship is a highly complex and critically important puzzle. So here's how they do it. When they draw plans for loading containers on a ship like the Arena, each one gets assigned a 6-number set of coordinates that dictates its exact position on the ship. I don't think you'll ever need to know how to read container ship coordinates, but I have plenty of time, and you might be able to use this to impress someone on the lamest date of all time, so I'm just gonna teach you how this works anyway. This 6-number digit tells you 3 things: the container's bay, row, and tier. Each one of these container ships is divided into bays, usually around 17 to 24 of them. And confusingly, each of these bays is actually 3 bays, as far as this coordinate system is concerned. Generally, a single bay can hold 1 layer of 40-foot containers or 2 layers of 20-foot containers. That means that each bay needs 3 different coordinate numbers. 2 odd numbers to represent the 2 possible positions of a 20-foot container in the bay, and 1 even number to represent the single position of a 40-foot container. Then all you gotta do is toss in a row number and a tier number, put them together, and mama, you've got a stew. As long as by stew you mean the exact position of an ISO container on board a shipping vessel. Now, the point of these plans is to determine the most efficient and least dangerous way to organize these containers on the ship. But as I mentioned before, this puzzle is complicated by the fact that almost no one at this point in the process actually knows what's in the containers. Instead, each container is marked with another set of numbers that contain just enough information to decide where on the ship they should go, and nothing more. The first and most obvious point of data known to the crew is the container's destination. Not all of these containers are being unloaded at the same port, so the route of the ship needs to dictate how the containers get stacked. Here's a pretty standard trans-Pacific shipping route originating in Qingdao, heading down the coast of China, then over to the US West Coast, and finally returning to Tokyo. The containers in a given bay would reflect this route from top to bottom. Anything that's only headed to the first port of Shanghai would stay on top, and anything bound all the way for Oakland should generally be shoved to the bottom. If a container bound for a later port is stacked on top of a container you need to unload now, you need to execute 3 crane movements instead of just 1, which, compounded over time, can become a huge liability as the cranes might get tired and not want to move containers anymore. That, however, is just a single factor in the placement of containers. We also have to deal with 2 other big problems: physics and chemistry, and also pirates. You know, the big 3. One of the other few points of data known about each container is how much its cargo weighs, and distributing weight across the ship can be surprisingly complex, or at least it seemed complex to my writer Ben, who hasn't taken a physics class since 10th grade. For one, there's the obvious factor that you need weight to be distributed evenly from starboard to port, lest your ship become considerably more upside down than desired. At the same time, that weight needs to be concentrated towards the bottom of the ship, because stacking heavier containers on top of lighter containers makes it more likely for the whole stack to collapse. But oh, not too fast! If too much weight is concentrated on the bottom of the ship, it becomes what they call stiff, and all of a sudden the entire ship controls differently. That's not even to mention the fact that each bay and row all have their own weight limits to prevent the ship from breaking altogether, meaning that weight has to be distributed evenly across 3 different dimensions to keep the ship upright. So already we have enough variables to bring Count von Count to climax, but we haven't even accounted for the slightly troublesome problem that these containers could contain almost anything. These ships transport raw meat, dangerous chemicals, million-dollar sports cars, bombs, drugs, illegal weapons, basically anything you could think of. In most cases, the contents of the container don't really matter outside of what they weigh, but in certain cases, they do. Take, for example, this container full of scrambled eggs. Why are you shipping 2,300 cubic feet of egg across the Pacific Ocean? Doesn't matter. What matters is the kind of container it's being shipped in. Perishable food, like your egg, needs to be shipped in specialized ISO containers called reefers, which are actively refrigerated with built-in water or air conditioning units. These, however, can't just go anywhere on the ship. Reefers need to be plugged into a power source, and only certain parts of the ship are equipped to power them. To make matters even more complicated, sometimes the contents of a container don't matter unless a different container on the ship is carrying some other specific thing. Basically, there are certain kinds of chemicals that need to be kept a certain distance from other kinds of chemicals. Containers carrying oxidizers, for example, need to be at least 6 meters from any other container carrying flammable gases. Containers carrying corrosives need to be in an entirely different hold than containers carrying infectious substances, and pretty much everything needs to be kept far, far away from containers carrying explosives. Oh, and also, you can't put any combustibles on the outermost layer of the ship if your route goes through here, here, or here, because pirates in these 3 regions have a mischievous tendency to shoot bullets at the container ships passing through, and you don't want their rude behavior to accidentally start a fire. Only once you've accounted for every single one of these factors can you solve your container ship puzzle. It's kind of like Tetris, if you think about it. The only difference is that it's slower, and you get to plan everything ahead of time, and all the shapes are the same, and if you mess up, it costs billions of dollars, and okay, it's not like Tetris at all, really. This is gonna financially ruin me. I spent like $20,000 on loading container ships as exactly like Tetris shirts that I was gonna sell at the end of this video, but no, that doesn't even make sense. I need to go make some calls. But first, if you made it to this point in the video, it's pretty clear that you have a particular interest in understanding how the world around you actually works. You've listened to me talk about the placement of identical metal boxes for like 6 straight minutes now. Unfortunately, getting an objective grasp on reality seems increasingly difficult these days, with the media we consume being polarized in one direction or another. That's why I get my news from our sponsor, Ground News. They're a website and app designed by a former NASA engineer on a mission to give readers an easy, data-driven, and objective way to read the news. Every story comes with a quick visual breakdown of the political bias, factuality, and ownership of the source's reporting, all backed by ratings from 3 independent news monitoring organizations. Take, for example, this article about American Airlines suspending flights to Israel until 2025. Right away, you can see some really crucial meta information that you're not going to get anywhere else. You can see how many sources are reporting on this, but also that many more of them lean right than lean left. You can see exactly who owns these sources and how factual those sources actually are. This can be especially helpful when reading stories from other countries where you might not immediately recognize the sources and have no basis for determining which are reliable and which are being run by total nutjobs. I especially like their blind spot feature, which shows you stories that are underreported by either side of the political spectrum. If you want to get a more well-rounded and objective understanding of the world around you, I can't recommend Ground News enough. And good news! HAI viewers can get 40% off a Vantage subscription right now by going to ground.news/halfasinteresting or clicking the link below. And when you do, you'll both support this channel and an independent news platform working to make the media landscape more transparent.